Welcome to part 2 of the Materialverse of Madness. If you didn't catch the first talk last month, doesn't matter. We will start from a fresh starter project. I will go into a few of the things that we are doing concerning materials. And today we will talk about blueprints, game logic, and basically try to create a little starter game for ourselves using blueprints. Because most of you maybe have done the Sum of Unreal or the EMEA initiative, and those trainings are more focused on the cinematic aspect of the Unreal Engine, where we try to create some sort of animation or movie inside of the Unreal Engine. And we talk about blueprint there as well, but we don't have too much time to go into the gameplay aspect of the blueprints. And that's why we thought this talk might be fun for you to get into it and learn a little bit about the basics of it. We will try to create a little prototype here. And yeah, let's get going. Here it says DroneSeeds Interactivity, and that's what we are going to talk about. If you don't know what DroneSeeds is all about, that's basically the project that I built for the material talk and this talk as well. All right, we're going to talk about blueprints today. And for the start, just for those of you who do not know me or do not know who I am, because not all of you I have trained. So this is me. I'm Stephan Rüb. I'm a digital content creator. I am a freelance 3D artist and Unreal Engine generalist, and I'm also an Unreal authorized instructor. I have other interests as well, not important for that. After this talk, I will share these slides, so feel free to hit me up. A quick agenda for the start, just so we know what might be interesting for you and what we are going to talk about. For the start, I'm going to give you a quick project overview. What's the state of this starter project and what we are trying to aim to create today. If we don't manage to get through everything, don't worry. Some parts of it are just copy-paste. Other parts of it might be interesting, and I might try to get into it later. And you also then have the finished project to download after this talk. So we will start with a project overview. Then I will do a quick recap of the Unreal gameplay framework, because that's what we're going to use today, just so you know how you might use this either in your own game that you might want to create, or just any interactive application that you are creating inside of the Unreal Engine. After that, we will create our game mode, player controller, and pawn, using those blueprint classes to create the interactive things inside of our game. We will set up some input actions and access events to be able to set up our flying movement and camera controls. And at that point, we can interactively fly through our scene with our drone inside of this world. Then we're going to talk about how blueprints can talk to materials, different ways of doing that, and different ways I have implemented in this showcase project. After that, we will create the functionality for spawning or creating trees and drawing grass, which is basically all of the gameplay functionality I have built into this. And at the end, a little question and answer session. Let's see how much time we have left. All right. So that's a quick overview. For those of you who didn't catch the first talk, the Materialverse of Madness, and haven't gotten around to watching the YouTube recording of that, this is basically a little project that I have set up to talk about materials, how you can use them instead of just like slapping colors on stuff, different ways of also thinking about materials. And I have used materials and blueprints in this little showcase project to create a little game prototype that you can try out for yourselves after that talk. So let me open up the finished version of the project. And let me show you what we're trying to create for today. So if I click play here, let me go full screen. I have this little flying drone. And this drone in itself is only one static mesh. The rotation of these propellers, of these rotors, all of this is done inside of the material, which moves all of the calculations of rotating an object from the CPU to the GPU, which just saves on performance. We can rotate our view of our camera around this drone, and we can fly. I'm doing this with a gamepad controller. You can do this with the keyboard and mouse as well. So we can fly around. You see the drone also behaves more or less realistic like a real drone would. So it is aiming or leaning towards the movement it is moving in. And you see also that the landscape transforms according to where we are. So it shows us only part of the landscape depending on where we are. The other functionality, of course, is because this DroneSeeds game concept is based on a future where humanity has failed to avoid the climate disaster. Maybe some of you remember my awesome trailer. And we have to replant, reforest the earth. And for that, the drone has different seeds that it can shoot into the ground, and then trees will pop up and grow instantly, because that's how trees work, right? So if I shoot this seed here, you see this tree pops up from the ground, and I can do this multiple times and spawn multiple trees. This is one type of tree. There's another type of tree, which is this one. And here we have a palm tree as well. And also you see, I also farted a little bit of grass here, so I can draw some grass underneath my drone. Right? Wherever I'm flying, while I'm pressing this draw grass button, I can draw grass on the ground. So that's the functionality we're trying to build here. The drone, the controlling of the movement of the drone, and the interactivity with the landscape, with the trees, with the grass. It sounds like not that much, but it is enough. All right. So let me get out of there, move this over here, and start over here. All right. I'm going to assume that you at least have some sort of Unreal experience. Like I said, maybe you have gone through our Summer of Unreal or the EMEA initiative, where you are already talking about blueprints. You know what events are, what functions are, what the construction script is, and how to move around in blueprints. You also talk about the gameplay framework there, but you're not using that specifically because we are talking about a cinematic aspect there. The gameplay framework is much more than only these three things that I'm showing you here, but those are the most basic ones that you might want to look at if you're trying to create your first interactive prototype inside of Unreal. The game mode on the left side is basically the rules of play. So, for example, who is controlling what is shown to you when you start in this level, what is happening, basically. So this is controlling many, many things. We will look at it in detail once we create it for ourselves. Then you have the player controller, and the player controller is the interface between a pawn, which is basically the next thing I'm talking about, and the human player controlling it. So it is basically you giving an input, and this input is going through the player controller to your pawn. The player controller can control pawns, so it can take possession of any pawn. And that's, like I said, the interface between you and the interactive application, be it a game or something else. The pawn, on the other hand, is the avatar. That's how you can think about it in your virtual world. It can be humanoid, so it can be a character, like Kanaski is, for example, or it can be anything else, like for us, in this case, it is a drone. It can also be a ball, can be anything you want. So that's the three most important aspects of the gameplay framework that we are going to talk about today. And before we move on, let's just set this up in our project. For those of you who haven't downloaded it yet, I have provided a link to the starter project for this. And there you have everything that's necessary to start and follow along. Let me open up the project. There we go. So your project should look like this. It should open up in the landscape 01 level, and it should show you an empty map with the sky. Okay. If you have this, let me close down the content browser. Let's open up the content browser and take a look at what we have there. Inside of our DroneSeeds folder, we have some sort of folder structure. I don't know why this is there. We have assets, we have blueprint, inside of there, nothing should be there. We have the maps, which is the landscape, materials, and textures. And inside of materials, we have all of the materials necessary to create everything that we have seen, such as the landscape, the trees, the drone, and everything else, right? This was part of the last talk. Inside of BP, which stands for blueprints, we have nothing yet, but that we can change. Since we talked about the gameplay framework, let's start with the first most important thing, which is the game mode. So right-click anywhere and add a game mode. I'm also going to assume that you know how to create stuff inside of Unreal. So create a new blueprint class. And from there, we can pick and choose a parent class. You know already about parent classes and children of parent classes. So I'm not going to go into this. You see, we have the default actor, which is the most basic class there is. Then we have a pawn that I already talked about, a character, which is also a pawn, but has additional functionality to it, which basically means that the pawn is the parent class of the character. Then we have the player controller, the interface between us and our pawn. And we have the game mode. Below, we also have components that we can create. Doesn't interest us right now. Let's start with the game mode base and create a game mode. Let's call that BP for blueprint game mode drone. This is our drone game mode. Okay. Double click to open this up. I'm going to close this instantly and open it back up so it comes up in the collapsed view. So if this comes up for you in this full blueprint view with all of the viewports and stuff, just close it back down and open it back up, because we're not going to add any components to it. That's not how it's meant to be used. The game mode is much more meant to be used to set up all of the default classes that you will use inside of your game or interactive application. So inside of this classes category, we see some types of classes that are meant for specific use cases. We're not going to talk about everything, but what we want is, for once, the player controller and also the default pawn class. Changing this will give us the opportunity to just be able to use this game mode, use a player start, and automatically we will spawn a pawn, use a player controller to control that pawn, and be able to instantly interact and play with our scene. Let me quickly go back to my map. You see in my map, we have this sky, this box, which is just collision, so we can't fly out of our world. And we have this player start, right? This player start object acts as a rotation, so as a transform, as the start for our play, for our scene. This player start is then filled, or at this player start location and rotation, there will then spawn our default pawn class that we set up in our game mode, once we set up the game mode to be used. And we can use the player controller to control that pawn. That's the basic gist of it. You can also just create a pawn, drag it in here, and say, I want to control that pawn. That works as well, but it is not considered best practice, and it is also not clean. Okay, it works, but you shouldn't do it this way, because the game mode can take care of so much more. For example, the HUD class, which is meant to be used for user interfaces, the player state class, the game session, and so much more. If you want to learn more about this, there's a great documentation out there, so feel free to take a look at that. All right, so we have created the game mode. Let's set it up that we also use it. A game mode is always level-based, right? You know this from the gameplay framework talk that we had in our blueprint courses. So we can set it on a per level or per map basis. We can change this either in our world settings here. If you don't have this open, go up to settings, world settings. Or we can also set this up in the project settings so that we have a default game mode if we don't override it in the world settings. Because you see in the world settings, we are overriding it. Depends on what you want to do. The quickest way is to just override it right here or set it up in the project settings. So let's just quickly override this here because we want to use this within this level only for our prototype. So in the game mode override, where it says none, just click on it and then select our BP game mode drone. All right. Once we have this set up here, we can also change in the selected game mode some of the default classes from here. So overriding them as well, but we won't do that. We will set this up cleanly inside of our game mode. Let's quickly create the two other classes that we need and then set this up in the game mode. So right click, blueprint class, and we're going to create a player controller. We're going to call this BP drone PC, so player controller. Naming scheme, it's completely up to you. We're not doing anything with it yet, just setting the assets all up. And then right click again, blueprint class, and this time we want a pawn, and this is going to be our drone. So pawn, BP, and we're going to call this drone pawn. All right. Let's quickly save all, just to make sure that we don't lose anything. And then in our game mode, we will set up to use under the player controller class, third one from the top, to use our drone PC. And you see it only shows us available controllers, available blueprints that use the player controller class. And in our default pawn, we want our drone pawn to be used. All right, compile and save. Good to go. To quickly test this out, we can just open up our drone pawn and put anything inside of it. Start the gameplay, start the play mode, right? Inside of our editor and see if this is being spawned. So easiest thing to do would be to add the drone, because we need it anyway, to our blueprint. And Zoom is not moving out of the way again. Okay. So let's add a static mesh component. And we're going to call this drone. Inside of the static mesh component, I'm going to assume that you know how to set up a static mesh. You can search for the drone here. I have two of them here. We're going to use the second one, so SM drone UV packed 02. You see the drone is already there, right? Without a material, we will take care of this later. Once I go back to my landscape now, having compiled and saved this, I can click play and see nothing happens. We are inside of the scene, but we don't see the drone, right? Why is this? If I press Shift F1 to get my mouse control back, I see in the outliner that a few more objects are now part of my scene because the game mode took care of that. We see we have the drone pawn here as part of our scene, and we also have the drone player controller that we have set up. But we didn't set up any camera angle, so we're basically inside of our drone right now. All right. Let's take care of a few components first before we take care of the interactivity. First, for the drone, let's set up the material that we have created in the last session. For this, since I want to be able to change stuff in it, I'm going to go into the construction script, create a dynamic material instance, and assign it to the drone. Sorry if I'm moving a little bit quick for today, but we have a lot to cover. So feel free to just watch the recording. All right, I'm going to create a dynamic material instance based on my drone material, so the drone rotation. All right. Once we have this, I want to save this as a variable to be able to access it later. So on return value, I'm going to promote this to a variable. I'm going to call this drone dyn mat. Let's make this even. Once we have this, we can get our drone as a reference here and set material so that this static mesh now uses this dynamic material inside of this blueprint. Going back to the viewport and clicking on compile, we see the drone is in place. All right. Back in the viewport, we now have taken care of the drone, but typically you also have another component that only takes care of the collision. So we don't have to set up some complex collision for our drone. We have just a really simple collision. Like in the third-person character blueprint, that's just a capsule, right? For this, we're going to use a box collision. So add a box collision here and set up the values similar to mine. So I'm going to set this to be 18, 28.5, and 6. All right. Then I'm going to attach the drone to that box and set the box as the default scene root. Okay. The drone will be rotated 90 degrees. And we will offset it a little bit so it is inside of the box, right? Okay. After this, we also need a camera. Like we've seen, we are inside of the drone. So let's take care of that as well. You have different possibilities to set up a camera. I'm going to use a really simple one. We're going to use a spring arm. And attached to that spring arm will be our camera. We are going to use a default camera, not the Cine camera, because we don't need all of that crazy stuff that the Cine camera can do. The spring arm is basically an object that offsets our camera, right? And we can set the length of this spring arm here in the details panel. We can also override it via blueprint. Let's set this to 250. And to be able to let it be controlled by us afterwards, I'm going to check on use pawn control rotation. All right. Okay, everything else should be good so far. I'm also going to disable collision tests. That's something that the spring arm can do so that our camera doesn't get stuck in some walls. But since we are flying and we don't have that many walls, it's okay. Sometimes it's glitching out a bit. So let's compile and save. All right. I think I rotated the drone the wrong way around, -90. Now she's pointing forwards. All right. So we have a camera, we have a drone. If we now click play, we see our drone in front of us, and that's what we want. Okay. So now we have taken care of the basic stuff. We have set up a game mode, we have set up a player controller and the pawn. We don't need the player controller specifically because we can also use a basic player controller that does nothing else than just being there. But I just wanted to show you that you can set this up and how. Next step is to talk about inputs, because to be able to control our drone, we have to have some inputs here. I'm still using the, let's say, old version of handling inputs inside of the Unreal Engine. Since Unreal Engine 5, there's the enhanced input system, which I have put a link inside of my slides to, so feel free to take a look at the documentation there. I'm still using the old one because since some of you might still be on 4.27 or on 4.26 for real projects, since this is also the way you do this in Unreal Engine 4, I have opted to go this way. The inputs are set up inside of our project settings, and we have different types of inputs. We have action and axis mappings. And those then provide us with different types of events that we can use inside of our blueprints to generate our movement or anything. This should already be set up for you inside of your project. Let me just quickly show you. So if you go up to Edit, Project Settings, and then under Engine, we have the input. And there we have all of the action mappings and axis mappings. Let me quickly talk about the difference between action and axis mappings. The action mappings are basically just a key, an input that is either on or off. So a Boolean, basically. The axis mappings is a digital, an analog input, which can have values in between 0 or 1 or -1. So it can give you an event and also according a value to it. For example, you have on your gamepad a button here, like X, A, B, and Y. These are digital inputs. These are action mappings because they are either pressed or not. On the other hand, these thumbsticks, they can move from 0, from its center, to this direction, to this direction, and to this direction, and also have different states in between. And those are the analog inputs, and those are axis mappings, for example. Can also be a mouse, can also be touch, can be so many things. So action mappings and axis mappings. Those should be already set up for you. Now we're going to rather quickly create our inputs for our movement in our pawn. All right. So inside of the event graph, inside of our drone pawn, we're going to start with the moving forwards, backwards, and sideways, just so we are able to move around. And then we're going to take care of the camera movement and then flying up and down. You see in our project settings, we have axis mappings set up for that. We have the fly up axis, fly down, the right movement and forward movement, and the camera vertical and horizontal axis. All of those are axis events because we want also to be to drive speed from it. In our drone pawn, to be able to use those inputs and move our drone around, we could do this just without anything else, but we can also let Unreal Engine help us. And for this, we have the floating pawn movement, which is another component. You might have seen the character movement component in the third-person character template. And we are going to use the floating pawn movement here. Just add this as a component, and this should be added to your list here down below. The floating pawn movement gives our pawn the ability to float, like it says, so we can fly. That's cool. Having this selected, taking a look over in the details panel, we can set up some settings here, such as how much speed can we achieve at the max, so how fast can we go at the max, full throttle. Then our acceleration, deceleration, and turning boost. Let's set up our acceleration and deceleration to be 1000. This worked well for this purpose, and leave everything else as is for now. All right. Now we're going to add the events for our inputs. So just right-click in an empty space. You know about blueprint graphs already. So right-click, input, axis. If you type in input axis, you get all of your input axis events here as a list. So we have the camera horizontal, fly down, fly up, forward, and right. Let's start with the forward movement because this is the easiest to understand, and then we will move on. So let's create the input axis forward movement. This creates an event for us, execution pin, and a float pin that gives us the axis value of our forward axis. Let me quickly jump back to the project settings, where we see that inside of our axis mappings, we have set up these axis names, and beneath that, we then have the mappings to the specific inputs, so the keys. In the case of the forward movement axis, for example, I've used the gamepad left thumbstick, the y-axis, so up and down, to be the forward movement. This will give me a value between 0 and 1, or minus 0 and minus 1. But I also have two keys, W and S, to be able to use the WASD movement. Those keys in itself are just on a keyboard, and they only have on and off. So I can apply a scale to them, so I know that once I press this key, this value will be given or scaled at this rate. For W, I want to move forward, so I want to scale this by 1, still the same. And for S, I want to move backwards, so I scaled this minus 1. Just so you know what's happening there. So having our movement axis in place, let's add the movement input. So get out of it and add movement input. This gives us a node specifically targeting the pawn, where we can pipe in a world direction, so the direction we want to move in, and a scale value to scale this movement. Get actor forward vector. And this is just the direction that our actor is looking at. Not the drone specifically, because we could rotate it like relatively to our actor, but the actor forward vector. That's important. Then the scale value can either be our axis value directly, because we want to be able to scale it, which will give us the ability to speed up and down, or we can multiply it by some value. For now, we just put this in straight like this, and then we should be good. If we compile and save now, and I go back to my level to test this out, and this will happen quite a lot today, we can already, if I click into it, move forwards and backwards. We don't see much happening right now because nothing's changing. We don't see a landscape, we don't see anything else, but believe me. All right. Next would be to be able to move left and right as well. It's essentially the same. I'm just going to copy over stuff from here. So this is the input axis for the right movement. And in this case, I have set this up to be the gamepad thumbstick, the left thumbstick x-axis, and D and A scaled 1 and minus 1 again. For this, we can also pipe in the axis value directly. And in this case, we're not getting the forward vector, we're getting the right vector. This is why we're always using the right movement axis, because the get actor right vector is just part of Unreal and gives us the correct direction instantly. To be able to see something, just to make this easier, we can quickly change up our landscape material, because right now our landscape material is trying to get the information from our pawn, which we haven't set up yet, to be able to show us only parts of the landscape. Let me show this to you in the finished example, because right now we see the landscape and it cuts off back there. If I fly to it, then it shows me part of this landscape. It's just masked off. We can disable this for now, just really quickly inside of the landscape material. So going into the DroneSeeds folder, under material, we find the landscape. And there we're just going to disconnect the sphere mask from the opacity mask. Saving this gives us our whole landscape back, right? So it was always there, it was just hidden. And now if we fly, we should be able to see that we fly forwards and backwards. But we see we can also fly through the landscape. That's because we haven't set up the collision correctly. We have created the collision object, but we haven't set it up to be colliding. The box collision normally is more used for overlapping, such as the capsule and sphere collision as well. So we have to change this in our details panel of the box collision to use, instead of overlap all dynamics under collision presets, block all. Just block everything. Or even better, we are using pawn because this is a preset specifically created for pawns. If we compile and save now, Let's take a look. Boing. We are hitting the landscape. All right. Come on. We can now move forwards and backwards and left and right. Let's take care of the camera movement so we are able to navigate around our drone as well. It is pretty similar to the input axis for the movement. In this case, we're just controlling another value. So let's create another input axis. I'm going to quickly copy this over here. So in this case, we have the input axis for the camera vertical axis. And this is just, in this case, multiplied by a rotation speed, which I don't have yet. So let me create this quickly. There we go. Rotation speed. Let me set this to a float first, so Unreal doesn't give me errors. Compile. And I'm going to set this to 0.5 because the rotation speed was too quick initially. Having this set up, we are adding to the controller pitch input. And what is happening there is that the controller is controlling our camera. And there we can just add to the input pitch and yaw to rotate our camera. And for this to work, we have to make sure that on our spring arm, we have checked use pawn control rotation, because that's what we are changing here. If we are not using this, the spring arm doesn't care about anything that we are doing here. Going back to compile and save in our level, I'm now able to move my camera, rotate my camera around my drone, and I can fly around. So with just a few nodes, you instantly have a playable prototype, right? Let's get into this a little bit further. I'm adding the leaning movement now. And like I did before, I'm going to just copy paste functionality over and then talk about it, because we don't have that much time to spend on those basic things. Okay. So there we have it. All right. Let me connect this and connect this and connect this. Okay, it's a little bit complicated right now, but bear with me. I'm going to get you through that. After we have added our movement input, we want our drone to always lean in the direction that it's moving, because a drone normally does this. When you watch a drone fly, it's trying to lean in this direction, like a helicopter does as well. And for this, we're going to give us the axis value and test if it is it is smaller than 0 or not. Depending if it is smaller than 0 or not, then we know if it's moving forward or backwards. And according to this, we have to lean our drone, right? And for this, we are using a select float, -30 or +30 degrees in angles. Then we're going to multiply this by the absolute value of our axis, which goes from 0 to 1. Once we have the result of this, we're going to interpolate our rotation on the x-axis, so the roll, because we're rotating forward, with the current rotation that it has. So it will interpolate between the current rotation and the new rotation that we want to set, with a given speed that we set up here. And then we're going to set the relative rotation, overriding that. Once I have this connected, it gives me an error. Let's see, yeah, because this is not named correctly. Let me just undo this. So we're referencing, of course, the drone static mesh here. And going into it, you see now it's leaning forwards and backwards and interpolating accordingly. Using WASD, in this case W and S only, it also works because we have this F interp in place. If I were to put this straight in here, it would just directly set up the rotation, so it would skip, basically switch, boop, boop, boop. And that's not intended. we can set up the same thing, basically, just on a different axis for our other axis, because the movement left and right is, of course, not leaning our drone forwards and backwards. It's leaning it left and right, like this. And that's just some really simple functionality that you can add with a few nodes to give it a bit more realism, or at least feel. So we're once again testing our axis value, getting the axis value absolute value, and we're getting our drone static mesh, putting it in here, and connecting it to the set relative rotation. And now basically our flying is already in place. Right? That's how our drone should move. We can also create leaning of forwards and back and sidewards at the same time if we press like this, because it is interpolating and getting always the current relative rotation as well. So we're never overriding. All right. That's basically it for this part. We now only have to implement the flying up and down, but that's really easy because it's just these nodes. We have one more time a fly up axis, which gives us a movement input that we need. And we just want to fly up on the z-axis because up and down is always z. And on the fly down axis, we do the same thing, but with z minus 1. I have done this in separate events. I could also do this in the same event and using the inputs for that. Just wanted to do it this way. All right. Back in my slides, we have now set up the flying movement and camera controls, and that's how it looks in the finished project. Next is how Blueprint can communicate with materials, and that's what I really wanted to talk to you about. So we are able to fly around our scene. Now let's set up the interesting stuff. So blueprints can communicate with materials in different ways. Either they can override set parameter values inside of a dynamic material instance, like it says here, and we have set up the dynamic material instance for our drone already. So that's something we're going to play with. And they can also override material parameters of a material parameter collection, which in turn can be used by many materials at the same time. There are also other options to do that, to communicate from blueprints to materials, and I'm going to show you another one later with the trees. In our engine, let's set up now the landscape that I had in the finished example as well, so that our landscape only shows us a circle around our drone, and we have this sort of functionality going here. For this, we have to set up our landscape material again. So plug in the MF sphere mask into the opacity mask again. Let me double click and go inside for those of you who were not there the last time. This material function just creates a little sphere mask, which is a virtual sphere mask positioned in 3D space that paints a black and white value onto our material, onto our landscape. This sphere mask is driven by the mask position and mask radius, and these are all material parameter collection parameters. To see where this is set up, inside of DroneSeeds materials, we have this NPC mask config. Double click. And there we have two parameters. One scalar parameter, which is the radius of the mask, and it is 2000. In this case, this is centimeters. And we have a vector parameter, which is the mask position. And this is what we are going to change. Basically, every time our drone moves, we want to know where the drone is, and this will be the center of our sphere around the drone. We're going to write a little function for that, nothing too fancy. And we're going to use a timer because tick is bad, as we know. So in our drone pawn, because the drone always knows where it is, it's easiest to set it up there. We already have a few default events here set up, like the event begin play, actor overlap, and event tick. Let's delete the begin overlap and the event tick for now. On event begin play, we want to start a timer that always updates our location of our mask, depending on where our drone is. So let's set a timer and set a timer by event. So set timer by event. The cool thing about timers is that you can attach an event to it, which will always be fired when the timer is up. And you can set it to looping, so it will always start again. Also, you could set it up as a variable to be able to clear and invalidate it, so to stop it. But since I want this to leave it running forever, I don't want to set up a variable for that. All right, so the values for that, I'm going to set the time to 0.1. So every 10th of a second, I'm going to update this. And I'm going to set the looping to true. Then I'm going to create an event for that. So just a custom event that I can connect here. So custom event. And I'm going to call this update timer. Now you might have not used this before, but you see on every event node, we have this little red dot at the top right side. This is a delegate. And we can connect this to this event dot here in the set timer by event. So this is now connected, and every time this timer is finished, it will fire this event, start again, fire this event. We could also set up a timer using a function, but I wanted to use an event because it's more clear, I feel, for beginners. Inside of this update timer custom event, I want to set a vector parameter value for a material parameter collection, this material parameter collection. So first, we need a reference for that. To get a reference to a material parameter collection, we can create a variable just inside of our blueprint. So under variables, I'm going to add a new variable, which is going to be the mask parameters. The type of this variable needs to be a material, if I can type, material parameter collection. Material parameter collection, and then object reference. Compiling this gives us the option to fill this material parameter collection with any material parameter collection that we have as an asset in our content browser. So let's fill it with the MPC mask config. And now we have access to all of these variables, all of the 2 variables. Let's compile and save. Drag and drop a getter for this variable into our node graph, and then set vector parameter value. Set vector parameter value from this. So we will want to set the value of this vector parameter, which is the location of our sphere mask, inside of our drone pawn. Unfortunately, this node is a bit broken. Normally, it should give us a dropdown with these parameters, but it doesn't do this. So we will just drag out of there, get a workaround, and make a literal name, because this is a name input, and just type the name in there because it's not that hard to write. It is named mask with an uppercase M and then uppercase position. This parameter value, this vector parameter value, let me connect this over here, is presented to us as a linear color, which is of course not right because we're not talking about color values, we're talking about locations. But this is all the same to Unreal. We can just right-click and split the struct pin, and then we have R, G, B, and A as separate channels that we can just put X, Y, and Z in and leave alpha alone because we are not going to use it in the material anyway. So how do we get the information now that we need for this? Let's create a little small function for that. I'm going to use a pure function for that and then pipe the information in here. So under functions, let's create a new function by clicking on plus and get current landscape height. Because the problem is, if we just take the drone position, our sphere mask might be really high and we might not see the landscape at all because our drone is far above the landscape, but we still want to see the landscape. So we're going to shoot down from the drone to the landscape, and where we hit it, there we want to place our sphere mask. Okay. So let's just get a reference to our drone inside of this function. And from our drone, we're going to get our world location. World location. Get world location. This will be the origin of our line trace that we are going to do, because this line trace can give us the information how far we are we are away from our landscape. To create a line trace, I'm going to just quickly copy this over. We have different types of line traces. I'm going to use the line trace by channel. So right-click line trace by channel, and there you can use this. This line trace has a start and an end. The start will be our drone world location, and the end must be anywhere on the landscape, or even farther than the landscape. At least it has to be so far that it hits the landscape. And since I have set up some collision bounds of our level, I know that we can't fly up that high. So we are going to just give it a really high value and hope that we always hit some sort of the landscape. We're going to use the get world location as well. So drag out of there and type in plus, and we're going to add another vector to that. This vector is going to be multiplied. So we're going to multiply this vector with a float value, which we can just do by right-clicking on the input pin and convert the pin to a float. That's new in Unreal Engine 5, really cool. And there we just type in an insanely high number like 500,000. Then we're sure to always hit anything. And then the result of this plus will be dragged into the end. So we have the line trace in place, we have the function in place. Let's, in our event graph, quickly call the function. So drag and drop a function in to create a function call inside of our update timer. This line trace, once it hits something, it gives us the information of this hit result, which is this out hit. This is a structure, so we can break the hit result. And there you see what type of information it gives us. It gives us the distance we traveled. It gives us the location, which is what we are searching for. It gives us the normal, it gives us the actor that we are hitting, the component, even down to the individual face that we are hitting, the individual polygon. So a lot of information inside of these traces. There are line traces, sphere traces, many types of traces. Also, the line trace by channel gives out a return value as a Boolean. So it tells us if there is a result at all or not. So let's just, to be sure, use a branch to make sure that we hit something at all. And then once we have the hit result, let's drag out of the hit actor and cast to landscape, because we only want to hit the landscape. And once we hit it, then something should happen, which is the location that we want to get out of here. For a function to have an output, we can either just select the function input and give us here an output with the plus here, or we can drag out from anywhere here, from a location, for example, or the distance, drag this over to our input pin, and you see there's a checkbox now, add pin to result node. This gives us a result node which has a location input right now. So connect this over here, connect the location to the location, and this is everything we have to do. Back in our event graph, so going back outside of the function, we now can get the location and pipe it in here. We don't even have to use the function as we use it here. We can convert it to a pure function. You don't have to do this, doesn't matter. And then split the struct pin and pipe in X, Y, and Z. We have to create another point in space that we can shoot from, that is outside of that box. Either we drag the drone lower, but then our collision might not work correctly, or we just attach something to the drone or to the box, doesn't really matter. That can be the origin of our line trace. And since we need to create something like this anyway, we're going to do this now. So add an arrow component. And this arrow will be our shoot origin. It can either be directly in the center and below the box or in front of it. And since we're going to shoot from it later with the seeds, we're going to just move it in front of the drone. Make sure it's outside of the box. And I'm going to call this shoot origin. This arrow will not be shown to you. It's just a helper object, which automatically shows you the direction. Compile and save. And inside of our get current landscape height, let's exchange the drone component for the shoot origin. Compile and save. And it still is not working. That's perfect. Let me quickly troubleshoot. Okay, get world location. Okay, of course, I haven't set up -1. So all is good, all is fine. There we go. So inside of our current landscape height, we obviously have to tell it in which direction to shoot, which I failed to do. So that's why it didn't work. All right, now we have set this up. And this is the first way that we can talk to materials. We can just set a parameter value of a material parameter collection. And this can be used by many materials. So this could change for the landscape, just how it is drawn. This could change for a grass material, where it is drawn or what color it has, or many other different things. So really interesting, the vector, the parameter values inside of a material parameter collection. The other way, of course, is to directly access a dynamic material that we have created, which is a material instance, so a dynamic material instance. And as we already created one, we already have one in our blueprint. For the drone, we have created a dynamic material instance and set it as the material for our static mesh. And for those of you who don't know the material, it is using world position offset to rotate the rotors of our drone inside of one static mesh without having to use skeleton meshes or separate components to keep the draw calls low. Inside of this material, we have set up a few parameters as well, such as this rotor speed parameter that we can use to override our speed or even to turn off the rotors completely. And that's what I want to do next. So inside of our drone blueprint, let me make some space over here. I'm going to move this up. And this is going to be our input. Movement input. It's always great to make comments. I have created some colorful comments in the finished version of this project. All right. Okay, so when do we want to stop rotating and when do we want to start rotating? First, we have to know how to access this variable or this parameter. For this, we have to get the variable of our dynamic material instance that we have created. So let's get a getter for that drone dynamic material instance. And then, like with the material parameter collection, we can just drag out of it and set parameter. If I just type in set parameter, you see we have different types of parameters we can change there. Notice that we can't change every type of material parameter from within a blueprint. There's no availability of a switch parameter, of a Boolean parameter, or so on and so forth. We can only change scalar parameters, texture parameters, and vector parameters. Those are the more basic ones. Since we have a scalar parameter that we want to change, that's great. So let's set a scalar parameter value. We can also get the scalar parameter value, so we can also read the information. We can't only write. So set scalar parameter value. And once again, we have to type in the exact name. That's a usability thing that should be fixed, I feel. So in the drone rotation, we have to take a look at how our rotor speed is written with uppercase and lowercase in mind, and then either copy and paste this or try to recreate it within our blueprints from the head. So rotor speed. Once we connect this node to any event, this will set our rotor speed to 0, which means our rotors will stop spinning. And when do we want this to happen? Maybe when the drone is on the ground, so when it is hitting something. For this, we can just use our collision box because this already takes care of hitting stuff. So scroll down in the details panel in the box, and on component hit, just click on plus. For those of you who don't know what this is, some of the components inside of a blueprint have some default events attached to them. And you can scroll down in the details panel and have a list of those default events. With a click of the little plus button here, you can just add the event to your blueprint. So on component hit, click plus, and there we have the event. Let me move this over. All right. Let's connect this over here, compile and save, and quickly test this out. So in my scene now, I'm flying. You see my rotors are spinning. Let me fly down to the ground, and you see my rotors stop spinning now because I have hit something. Now, of course, we also want our rotors to start spinning again when we want to fly. Different ways of doing that. I have attached it to my fly up axis because when I'm flying up, I obviously want my rotors to spin. And normally, if you're flying a drone, you're not starting to fly forward instantly because your drone might not like this, and your floor also might not like this. For this, I just have created a little functionality here like this. Let me quickly fix this up and then talk about it. So on my input axis fly up, so if I'm pressing the fly up input, I'm checking if the fly up axis is above 0.5. I know it's always positive because this fly up axis is only using the triggers here at the back. If it is above 0.5, I just want to set my scalar parameter value, my rotor speed, back to 3. The original rotor speed is at 1 for now, so it will change in this case. Let me preview this for you. You see the rotors are spinning rather slowly. This would not keep our drone in the air. If I move down, you see they stop spinning. And if I move back up again, if I can, my collision is a little bit weird today. Hello. They should start spinning again. And that's just great. That's everything is working today. Okay, let me see if I can fix this quickly. It's really weird. Let me just try out another space on the landscape, maybe here. Yeah, and there we can fly up. It's just a weird landscape. But yeah, you've seen it, it works. So that's another way of communicating from a blueprint to a material by just setting the parameter value of any parameter from a dynamic material instance of that. And this has all the advantages of the material instances that you do as assets in your content browser as well. So you just have one material, one master material, can create infinite dynamic material instances of that, and then drive values via Blueprint in real time, dynamically. All right. Now we have set up the basic movement of our drone. It can land, it can start to fly again if the landscape wants it to. And now we, of course, want to take a look at the real world, the real interactivity. So the shooting of the seeds, the drawing of the grass, the spawning of the trees, all of that. How do we do this? Let me switch back to my slides. Spawning trees, let's take care of this once we have set up the actors for that. Anything else I have already covered. So let's create first the actor classes that we need. Switch back to your content browser and go to your Blueprint folder. Inside of there, we only have taken care of our game mode, our player controller, which doesn't do anything specific right now, and our pawn. The pawn does a lot of things already. The game mode just tells us or tells the game what to spawn. Now we need two more classes. One class is going to be the projectile, so the seed that we're going to shoot. And the other actor will take care of all of the trees. Okay, so right-click and create a new actor class, new Blueprint class of the type actor. Let's select actor here. And we're going to call this BP seed projectile. Double-click to open this up. And for this seed projectile, I haven't prepared a really cool, awesome static mesh for this because we can just use a sphere. Once again, we will replace the default scene root with a collision object, just so we're able to collide with something. We're going to add a sphere. In this case, just a sphere collision, right? Sphere collision. And drag and drop this on the default scene root so it replaces it. The sphere radius I'm going to set to 10 centimeters because our seed is small. And then underneath that, I'm going to add another sphere, and this time a static mesh. Right, this sphere, which is our seed. I'm going to scale this down as well to 0.1 and 0.15 on Z, just so it looks a little bit more like a seed. We're not winning design awards with this. That's okay. All right, on the sphere collision, let's scroll down and make sure we have set up our collision correctly. Let's set this to pawn as well and compile and save. To take care of the movement, just so you know what I'm talking about, if I'm shooting a seed in the finished version, right, shooting a seed, it already flies out into the distance. But what I'm only doing is spawning this actor. So I'm not adding some velocity to it. That's something that the actor does all by itself. For that, there's another type of movement component, which is called the projectile movement. A projectile movement component. This can automatically shoot your actor once it spawns into the world. And this is also used, for example, in the first-person template that the Unreal Engine has, where you have a gun and you can shoot this little ball that bounces around. This also uses the projectile movement. Let's take care of our seed spawning, so the shooting mechanism, before we can take care of the trees. So inside of our drone pawn, we now have prepared the seed actor class. We're going to move down a bit and for the first time use our input actions. So input action. Type in input action, and there you see draw grass, shoot seed, conifer for this type of tree, shoot seed for the pawn tree, and shoot seed for the, let's say, default tree. Let's start with the default tree. And this gives us this event. It has an execution pin for pressed and for released. So anytime we want to trigger something by the pressing of a button, we can attach functionality to it, and trigger something by the releasing of a button, we can add anything to that. All right, let me copy over the thing from here. And get the shoot origin. So what I'm doing here is I'm spawning the actor seed projectile. This is just a spawn node, spawn actor from class, right? This node. And this, I can set a specific actor class. You notice that this class is violet because it is referencing the class and not a specific actor instance. It is referencing the class itself. So it will spawn an actor of that class that I set here, which is the BP set seed projectile. Let me quickly set this up so I'm using the correct one. Okay. And then I can give it the transform, location, rotation, and scale where this should be spawned, which I'm deriving from my shoot origin, which I have set up before, right? This one. So I'm getting the world location because spawning an actor always happens in world space. And the rotation I will draw from my control rotation because I want to shoot forwards. The scale is fine. We can leave this on default. And then under collision handling override, I'm going to always spawn and ignore collisions because the seed doesn't care about collisions. Let's see how this looks. Compile and save. And just so you know, the input action for this shoot seed tree is either F or the gamepad face button left. Depends on if you have a gamepad attached. So here, gamepad left, you see it shoots a seed. Really cool. The projectile movement component is not really that impressive for now, but let's fix this quickly. In my projectile movement component, I set up the initial speed to be 3000 and the max speed also to be 3000. Compile and save, and testing now, shooting the seed. It looks much more like it's shooting out. The seeds will just keep on the ground. They will just stay there because we haven't told them to disappear. That's what we can do next. So in our drone pawn, once we spawn the seed, we don't have to take care of anything else because the seed will take care of it. Inside of our seed actor, in the seed projectile actor, we'll one more time use our sphere collision like we used the box collision, scroll down, and on component hit, do something. Because once we hit something, we have hit something, and we want to either spawn a tree or spawn another tree. We're going to create a sequence here, a sequence of functionalities. This will basically be the same thing as attaching multiple function nodes one after the other, and then adding another function node after that. So it's just in series. The first part of this we can take care of once we have created another actor class. So we will leave this empty for now. The second part is really easy. We will just destroy the actor. So when we hit something, we just want to be destroyed because then the seed is in the ground and the tree is spawned. Compile and save. Quickly test this out. Pressing this should spawn a seed. Might be hard to see, but it's spawning the seed, and once the seed hits something, it's destroying itself. All right. Let's get to the real interesting part, which is the trees. For this, I have created another blueprint class. So blueprint class actor. And I have called this BP tree manager. And for today, we might only get to creating one tree, but all of the other trees are the same. So that's fine. Let's open up the tree manager and take care of the tree itself. So first we have to have a tree to be able to, or a reference to a tree at least, to be able to spawn it. To save on performance and draw calls again, I used instant static meshes. And let me show you this here. For spawning trees, we are using instant static meshes to save on draw calls and performance. To add a tree, we can just add an instance to the instant static mesh component. And for the growing animation, we can just pipe through the current time of our game into our material. This might not make sense now, but let me fix this for you. So in our tree manager, we will add an instant static mesh component. So type in instance. You can use either the hierarchical instant static mesh or the instant static mesh. Doesn't make much of a difference here. I'm going to use the first one and call this trees HISM. This is basically a static mesh itself, so it can reference a static mesh, and then we can add instances to it, and then they will be optimized in terms of draw calls and performance, because it will only call once for all of the instances, but we can still individually address the instances. We could also scale them using a timeline and a blueprint, but then this scaling animation would have to be executed on the CPU again, and we want to let the GPU take care of this. First thing to do is to set up our tree inside of here. So in the static mesh slot, let's type in tree, and let's select the SM tree simple BC1. Make sure that the material is set up to use the tree material as well, because only then our effect will be applied. Compile and save. And we can switch over to our event graph. Before we do this, notice that we have added a static mesh to our instant static mesh component, and we don't see anything, because per default, those instant static mesh components don't have any instances attached to them. We can add instances also here in the details panel. Here under instances, I can add one. Come on. Right? And there we have a tree now, because it relies on these instances. The instant static mesh component itself is basically a little small container for the individual instances. All right, I'm going to delete this now, because we want to add our instances dynamically. In our event graph, let's delete the default events, just to be clean. And then we're going to create a custom event. So custom event. We're going to call this spawn tree, even though we're not really spawning something. And for this spawn tree, we want a input in this event that we can drive through from our seed, so that it knows where it needs to be spawned. So select this custom event, and on the right side in the details panel, under inputs, click on plus and type in location. Set the variable type to be a vector. And now we can use a vector location that we can set every time we call this event. And this will be piped through, and we can use this for our instance adding. Let me quickly copy over a few notes from here. They are not that much. And set this up. Didn't want to copy over this specifically, but doesn't matter. All right. So to add instances to a hierarchical instance static mesh or an instance static mesh component, it's just the add instance node. So you can drag out of your instance static mesh component and say add instance. Or you can also add instances using an array. When you add an instance, you need to tell it where it should be added, like the rotation, and the scale. And for the rotation and the scale, I have just set up a random float in range to be used for the instance transform Z. So our trees are rotated on the Z axis randomly, just to create a bit of randomness. For the scale, I also used a random float in range between 0.75 and 1.25 and scaled this with a normalized factor, just so our scale is also a little bit varied. And for the location, you just have to pipe this in here. Okay, so once we know the location and this event is fired, we can add an instance there. Notice that this gives out a return value as an integer. And this is the current index in the array of instances that our instance static mesh has. So we can always get to this specific instance once we add it. This will be necessary for later. Once we have set this up, we need a possibility to call this. So let's compile and save, just to be sure. And inside of our seed projectile, once we hit something, let's cast to that tree and to that tree manager, and then call the event. Normally, you could also use an interface, a blueprint interface for that, for blueprints to communicate to each other. This is the cleaner approach. But for this prototype, I felt it was easier for you to understand what we're doing here, that we know what's happening. Okay. When this sphere, when this collision, this seed is hitting something, we first have to check if it is hitting anything but our landscape. And since we know that we have, for example, a drone pawn, we want to make sure that once we hit our drone pawn, that not a tree gets spawned on our drone. So dragging out of other actor, this gives us the information of the actor that is being hit by this seed projectile. So dragging out of there, and then cast to drone. Cast to drone pawn can make sure that if we only drag out of cast failed, we will not hit our drone pawn. Different possibilities of doing that as well. Welcome to blueprints. Dragging out of it again and cast to tree manager will also make sure, connecting this to cast failed, that we don't hit another tree that is already in place. Because if we do this, we might be able to stack trees on top of trees. We could also disable collision completely for our trees, but then we could also fly through them. So that's not good. When this cast also failed, we can get actor of class. We can either get all actors of class or get actor of class. Get all actors of class is really expensive, so try to stay away from it. Get actor of class is also not that great. Normally, we would set up some reference to this earlier, or get a reference to this from the game mode or something like this. But like I said, we want to still try to keep it simple and be in this prototyping phase still, okay? So get actor of class. And then we want to get an actor of the class tree manager, because we want to reference it to be able to call the event. Compile and save. And out of this return value, we should now be able to spawn a tree. So spawn tree. And there we can give it the location. The cool thing about this on-component hit event is it gives us also the hit structure here. So we can just drag out of it, break it again, and get the location from there. And that's the location that our seed hit the landscape in this case. And there should a tree be spawned. Compile and save. If you try this out now, this will not work because we don't have a tree manager in our scene. The easiest way to do this is just to spawn a actor of BP tree manager at the beginning of the game. And since we have a really empty and sad player controller, let's do it inside of him. So open up the BP drone PC. And let's take a look here, just so we understand what this is doing. The player controller takes care of a lot of things. Like I said, you don't have to create one if you don't want to change the default settings, but if you want, you can open this up and, for example, take a look at the class defaults here in the details panel. You can set up the mouse interface. So, for example, if the mouse cursor should be shown, this is set up in the player controller. Also, you can enable or disable click events, touch events, mouse over events for 3D geometry. So there is also an event inside of an actor that is on clicked when I was clicked. Really easy, but you have to set this up in the player controller. Also, there's a camera manager. So if you don't set up any other camera inside of your pawn, then this backup camera basically will be used. That's the player controller. But of course, it also has a default, like a normal blueprint graph where we can set up any type of functionality. And on begin play, let's just spawn actor from class like we have done before. We want to spawn a tree manager. And the collision handling override always spawn. We want to ignore collisions. If we compile now, it gives us an error because when we spawn an actor, it always has to know where it needs to be spawned. We have a spawn transform input here, and we need to put something in. If we don't want to create a variable for that and like fill our blueprints up with infinite variables, we can just right click and split the struct pen. This instantly gets recognized as an input. And if we compile now, the error is gone. So save and go back to the level. If I click play now, you should be able to see that we now have a BP tree manager. There we go. Still really weird, but I spawned a tree. Like I said, take a look at the finished example if you want to really dive deep into it. Now I spawned a tree, but it instantly was at 1:1:1 scale, or at 0.5, like White said with the random offset. To be able to scale this up and down, we have created a material function for that. So inside of the material of our tree, let me quickly show you. Here, the tree. Under world position offset, we're using this again. We have created a little function here, the growth, that uses the time. From the time we subtract something, multiply this by 2 to increase the speed, and then using the material function stylized growth, which just subtract the object position from the absolute world position from the object position, so scaling everything down to its origin, and then doing a little bit of math here, so it pops up and down. We have to take care of this input value because what I'm doing here basically is creating a little timeline. I'm using time, which always gives me the current time. And if I subtract from the time the current time, the time will move on. This will always be updated. And once the time is moved on to 1, I have given in here, this input, a value from 0 to 1 that is animating, that is changing. So it just instantly gives us a timeline, basically. I have used the per instance custom data node, which is a really interesting node, a bit complex to understand at first, because it doesn't work if you just straight put it into your base color, for example. This is vertex data. There is the vertex interpolator for this, but I don't want to get into the details material-wise for today. Just know we have set this up with the per instance custom data. And now to know how to use this, we have to, or where to use this, we have to go back into the tree manager. So when we spawn a tree, we also want to tell this instance the current time. Normally, this is really complex because we can't access stuff on a per instance basis. This is the only way that I know of in a material that you can access data on a per instance level. You could set up a scalar parameter that we change, but this would change this for every tree, right? There's also the per instance random, which just gives us a random value, which doesn't help us at all. So the per instance custom data gives us the opportunity to do this. For this, I have used the, set custom data value. This is a blueprint node that is targeting instance static mesh component once again. So we have to pipe in a reference to our instance static mesh. And then we can give it the instance index, which we know is the return value of the add instance. We have just added it, so we have the information already here. So connect this over here. And then you have different types of custom data. So you can add multiple indices, so an array of custom data that you can set up in your instance static mesh component. I have just used the first one and piped in the get game time in seconds into the custom data value. In my trees hierarchical instance static mesh component, I have to type in custom data, and I have to tell it first to have slots for this open, basically, to be written in. So under number of custom data floats, I just typed in 3 because I wanted to use different data floats afterwards. I didn't use them. You can also type in 1, compile and save. It's weird that it's not spawning. There we go. So I just have to press multiple times, but you see now the animation is happening. And this is due to the fact that we given the material the information of the current game time for the instance specifically, which is something that is really powerful, I feel. So you could implement this in so many different ways, like, for example, with the trees, with anything else. Being able to give over custom data on a per instance level is so powerful, specifically if you want to save on performance and move performance cost over from the CPU to the GPU. Let me move over to my slides. And here you see it once again. In the finished project, I have just created a function for that, where I can create the same thing for this the default tree, then the conifer tree, and the pawn tree. For the grass, let me cover this rather quickly. I'm going to switch over to the finished project and just talk over it, just so we have a little bit of time for a question and answer session afterwards, because I know you might all be a little bit confused. The drawing of the grass is done using a render target. Another way of communicating with a material using a blueprint is a render target that you can dynamically draw on, and this data can then be used by the material as a mask, as anything. So let me quickly show this to you in the finished example, just so I don't fumble around. In my drone pawn, I have another input, so I have my shoot tree seeds. In the finished one, I have another enumerator, so I can switch between the types of trees. I just have different input actions for the different trees. And I also have an input action for my draw grass. And like I have shown you before, the draw grass happens when I keep my button pressed. The button for draw grass is the top button, so the Y button on the Xbox controller. And by doing this, I'm just changing a Boolean value, is drawing grass, from true to false. So if I have pressed this, it is true. If it is false, if I released it, it is false. Then, inside of my update timer, where I also take care of the landscape material, since this is already ticking basically, I'm just asking if I am drawing grass currently, because I want this to update all the time. And when I'm drawing grass, I created a function trace for landscape. So let's click inside of there. Inside of this function, I'm once again getting the world origin for the world location for the shoot origin, tracing downwards. And I didn't delete all of the nodes. And then I can draw to a render target on that. It is a little bit complex because we have to take care of all of the scaling and sizes of the textures. So let me just show you the render target first. The render target is a texture asset that you can create by just clicking on right click, then textures. And there are different types of render targets. There's the 2D array render target, canvas render target, cube render target, media texture, and the render target. The media texture is not really a render target, but it's also a dynamically updating texture, which is being used for movies, for example, movie clips that you can import into Unreal and play. I've used the default render target, really basic. Double click to open this up. There you can just set up a size X and Y, which is the resolution of this dynamic texture. Don't set this too high because updating a 8K texture every frame might not be the best idea. So I've just used a 256 by 256 texture for that. Inside of the material now, it is inside of the landscape, for example. I have used the render target here using the landscape coordinates because it is a landscape material. I've just saturated them just to make sure because I'm adding stuff to it. And then I've multiplied it with some noise texture just to make it look more interesting. This is then being used in a lerp, lerping between the two colors of the earth and the grass. Really basic. The only other thing in the landscape material is the sphere mask. The other thing that gets affected by this render target is the grass. So inside of the grass here. Sorry, there we go. I have set this up to be used in the world position offset. So I have my wind for my grass, so it moves around. And added to that is the render target here as a mask for my stylized growth function that I've also used for the trees. For this to work, I have to divide this by the size so that this render target is basically scaled in world size to the landscape. So they are both at the same location when I draw onto it, and the grass does not get spawned over here when over here at the landscape something is happening. So I have to make them the same. So I've divided by 256 plus 2 zeros because meters and centimeters. Then masked out R and G because I only want to place this out or project this in the X and Y axis. And then just use the render target, the red channel because it's black and white in this case, doesn't matter what channel, pipe this in as a mask input. I've drawn this then here, begin draw on render target using this functionality. I get the location of this hit result, hitting straight down from the drone. Once I get the vector, I will break it. Sorry about that. I have to clean that up. Sorry. And then I will make a vector 2D because everything that's happening inside of a render target is always two-dimensional. So outside of this vector 2D, I do some other calculation so that I'm drawing at the correct relative location inside of the render target concerning the real world location, because I have to scale down or transfer the vector of the real world into the vector or the pixel position of my render target of this texture. And then I use the draw material function, which gives me the option to use a material as an alpha mask, basically, to draw onto my render target. I'm using this brush material, which just uses a radial gradient exponential, so just a circle. Right, so I'm just drawing a circle on there. Then I pipe something into the screen position, which is the position on the texture, basically, and the screen size, which gives me the ability to scale up or down what I'm drawing. The brush, basically, the brush size. And that's all there is to it. Once I have set this up, I can play. And if I, oh, sorry, that's the wrong key. If I start to draw now, you see grass getting added using this render target. If I get out of here and open up my render target now, you also see some little squiggly line. And that's what I have drawn dynamically during the gameplay. All right. That's all I wanted to cover. I know it was a little bit confusing today. Sorry about that. But I hope you got the gist of it. And that's mostly what I wanted to give you, basically. It's not a step-by-step tutorial. It's more a showcase on what you can do as a first prototype and a little bit more advanced stuff, talking from blueprints to materials and using the world position offset as a little performance boost that you can use for specific stuff. Like I said, you will have access to the finished project. I will upload this later today or tomorrow when the video gets released. I think this will be tomorrow or a few days from now. Feel free now to ask me anything. I will try to stick around and answer as most of the questions as I can. The blah blah is interesting to you. That's great. So instead of get all actors from class, we have done this in the seed projectile, right? Where we are referencing. In this case, I also did get all actors for class just because I wanted to set this up as a really beginner project so you all understand what's happening there. Get all actors from class just is a pretty expensive call. The way to set this up would be when we set this up in our player controller, because we're spawning it from the player controller. Just promote this to a variable and then access that variable because we already know this is valid. We have spawned this on begin play. So how we would do this normally is promote this to a variable and say tree manager. And then inside of my seed projectile, because everything inside of my game that uses this game mode, which uses the player controller, can access the get player controller. This is a default functionality. This gets you the player controller. This I could then cast to the specific player controller class, so my drone player controller. And there I could access the tree manager. And this would be much cleaner. There are many other ways, but this is a basic way that I think is understandable. It's just if you're just referencing a specific actor, this could also work. Interfaces would be if you had also a reference to the actor already. And since we are not hitting the actor, we would still have to get a reference to that actor, which would be get all actors of class, or get all actors in, I don't know, a radius around my hit point or something like this. Yeah, a minimap, right? That's what you're talking about, basically. Something similar to a minimap. Yeah, for that, I would not use the game mode. The game mode is part of it, but I've talked about this here. So if I open up the game mode, we have the HUD class. HUD stands for head-up display. And this is where you can handle, or should handle, all of your UMG, so your user interface classes. These are specific types of blueprint, and maybe we'll do a talk about this as well, how you can create user interfaces, doing, for example, a minimap, or like status bar of how many trees you have spawned already, how many trees you have seeded already, or I don't know, a menu, like a pause menu, a main menu. Everything like this should be handled inside of the so-called UMG widget blueprints, and they can then be spawned or created within this HUD class. So this would be handled in a user interface like UMG, and there you could use also the render target or something else. Not really. So I don't know if there's like a plugin to create UMG from Figma file. I don't think that exists because the way Unreal handles user interfaces is still a bit weird, specifically if you're coming from a UI design background. Because you have like scaling, you have DPI scaling in place, you have also responsiveness, but it works very differently from, let's say, the web, for example, or like different other app design stuff. So UMG is a bit weird in that way, because I think its origins are just rather far back. They haven't changed much of the basic core of it, but it is quite powerful, specifically in Unreal Engine 5. So sorry, I can't answer the question with anything specific. I don't think there is something like creating a UMG widget from a Figma file. I don't think this exists. Cool. So thank you all for your time. Thank you for attending. Hope you have a great evening or day or whatever, wherever time zone you are in. And maybe I'll see some of you in the next training or just in the Ingress Unreal circle. All right. Cool.